Hello, my friends. In this video, we'll be taking a look at the autosomal DNA results, predicted phenotype traits, and G25 results of another Russian from the post-medieval period in Suzdal in Vladimirskaya Oblast in central Russia. Now, this region of Russia is very key to the foundation of Russian and Muscovite Empire, and it was also part of Kievskaya Rus of Kiev and Rus. It is sort of the key foundational region of the Russian ethnicity and Russian people. It is definitely central Russia. It is very close to Moscow. All the central Russian cities like Kaluga, Tver, Yaroslavl, Kostroma are all nearby. And in terms of genetics, people who live here are very similar to Ukrainians, Belarusians, Polish people, and the rest of Eastern Europeans. Now, in terms of people who lived here in the post-medieval period, they were pretty much the same as Central Russians who live there now. So they're similar to Russians from Tver, Ryazan, Kursk, Oryol, Yaroslavl, and then there's Ukrainians and the Mordvins as well. So they're very similar to various Eastern Europeans. And the sample we're analyzing today is KED003. And this sample is a female, and she is also very similar to various Eastern Europeans, which includes Russians, Ukrainians, Polish people, and Belarusians. What's interesting about the Russians from Suzdal is they went through a very major transformation. So in the early medieval period, they were very different from the way they were in the later medieval period. So in the early medieval period, they were very northern. They were more similar to people from, Finland, Karelia, even maybe they were much more northern, like they were more Finno-Ugric in their ancestry. But then there was a population shift, and by the time that by the 15th and 16th century, so by the post-medieval period, they were already similar to Eastern Europeans. And this individual we're looking at today, KED003, this sample is already a Slavic sample, very similar to Ukrainians, very similar to Polish people. So this sample is already a Slavic Russian sample. So let's get into these results. She's a female. She does not have a Y DNA. Her mitochondrial lineage is I1A1. Very, very interesting mitochondrial lineage. I don't think I've seen this before. It does look like a Y DNA actually, because I've seen I1A1 as a Y DNA before, but it looks like it is indeed a mitochondrial lineage, and it does come from looks like it comes from N1A1, which also looks like a Y DNA to me. But indeed, this is a mitochondrial lineage. I don't know much about it. If you do know what it is, leave your knowledge in the comments. But her mitochondrial lineage is I1A1A3A. Very, very interesting. Let's look at what she scores with Manashakot and what she looks like and what her traits are, which includes appearance, diseases, and predispositions. So it looks like she has brown eye color, brown or hazel eye color. There is quite a low predisposition to blue eyes, only 0.5% also blue eyes. So she's definitely quite dark. Brown, hazel, or dark brown eyes most likely are her eye colors. Although there is a 6.3 odds of green eyes and 8.3 odds of blue eyes with a neighbor center. For hair color, she most likely has dark brown hair, although there is also a 25.3% odds of light brown hair and even 11.8% odds of dark blonde hair as well. Most likely she has dark brown hair though. And for skin color, she most likely has olive or Mediterranean skin tone, although there is also a 31.6% odds of white skin. So most likely for skin tone, she's got either olive or I should say olive, because I've been corrected before on this topic by people on YouTube. So she's got most likely olive or white skin, dark brown hair, and brown eyes. And for hair texture, it looks like she most likely has straight hair. And for nose shape, she most likely has snub-shaped nose. Now for coloring related variants found in the file, it looks like she has two light color variants in this variation of HERC2, and actually two light color variants in all of these variations of HERC2 besides this one, which is very interesting. So with SNP3, we can expect some sort of a lighter prediction, maybe green or hazel, maybe blue. But she does not have blue haplotype 3, and she does actually have this genotype right here. So she does have blue haplotype 2, at least this genotype right here. There is a dislinkage, so she does not have this variation. which is also predictive of blue eye haplotype 2. So with SNPR3, I'm suspecting she would score green or hazel because of this dislinkage. With YSEC, she would score blue, but that's completely deranged because YSEC uh, is the YSEC prediction for eye color is not even polygenic, so we can't really take that into account. But with SNPR3, I'm suspecting she's gonna score green or hazel. We can check that in a couple seconds, in a couple minutes maybe. She does have blue haplotype 1, so overall it's very interesting why she's scoring brown eyes. We're gonna find out in a couple minutes. So she does have two light color variants in variation of SLC24A5, and she also has two light color variants in all these variations of SLC45A2. So why does she score brown eyes? Well, um, it looks like she doesn't have any light color variants in this version of TIRP1, and no light color variants in TIR, and no light color variants in this version of IRF4, and what else? There's got to be other reasons. Um, no light color variants in this version of SLC24A5, 445A2, and she doesn't have any light color variants in this version of OCA2, okay. And I guess it's because of this genotype right here in HERC2. I guess this is the biggest contributor to her scoring brown eyes. But it's just kind of weird that she's scoring the way she is for eye color. I guess she is scoring 8.3% odds for blue eyes with a neighbor center still, which is kind of high. I don't know. 8.3% odds for blue eyes with a neighbor center is pretty high. So it's not a like 100% odds for brown eyes, but still she's scoring pretty high for brown eyes. Okay. Let's look at what she scores with SNPR3. I'm a little bit surprised at this prediction. Alright, and with SNPR3 she scores green or hazel. Yes, so I was sort of expecting that. So with SNPR3 she scores green or hazel, then brown, then blue. Yeah, and with YSEC she would score blue, but YSEC doesn't matter because with YSEC it's not even polygenic whatsoever. Alright, let's look at the phenotype oracle. And for the phenotype oracle, the closest phenotypes to her are this, which is a Uralid phenotype, and the second closest phenotype to her is this, which is a Alpine phenotype. So in terms of phenotypes, this phenotype is, I would say, quite foreign to Russians. There is a meme on the internet that a lot of Russians look like this. That's not really true. Uh, I would say the bottom phenotype, like this Alpinite, is a lot more common in Russians than this top. This top phenotype, Volgid phenotype, is definitely quite foreign in the Russian population. And if you see Russians who look like this, most of the time they have some sort of foreign admixture, Tatar or maybe some kind of Turkic or Caucasian admixture somewhere in their family tree. Most of the time, Russians who look like this have some sort of foreign admixture in their family tree. But this Alpinid, very very common, very typical phenotype for Russians, and this bottom phenotype, Celtic, Saxon phenotype, also quite common for Russians. There's definitely quite a lot of Russians who have this type of look. And for the two-way admixture oracle, looks like the closest phenotype mixture is a mixture of this plus this, followed by. Did I go over the? Wait. I was so caught up in the coloring. So she's got straight hair and she's got snub-shaped nose. Yes. So that's quite important as well. So straight hair and snub-shaped nose is a part of the reason why she's scoring all these potato phenotypes. So this is quite a potato phenotype if you look at the nose shape and the eye shape and the face shape in general. This Alpinid phenotype is also quite a potato phenotype. So these potato phenotypes are showing up closer to her than this, the Celtic phenotype. The Celtic phenotype is not necessarily a potato phenotype. It's sort of between potato and sharp, and it's showing up third close to her because she does have European facial morphology, or at least I assume she does. But the closest phenotypes to her look like seem to be potato phenotypes. This on top and this second phenotype to her, closest phenotype to her, are both potato phenotypes. And the closest mixture is a mixture of potato plus sharp, then potato plus potato. Then another phenotype mixture is a mixture of sharp but kind of ethnic looking plus potato. then potato plus potato, then potato plus white. So essentially, she's kind of a little bit exotic looking by Russian standards. Russians tend to be a little bit lighter, and all these phenotypes are quite dark, except for this on the bottom, the corded phenotype with hazel eye color and brown eye and brown hair. This maybe is rather typical in terms of Russian pigmentation. I'd say it does fall within the general range for Russians, but all the rest of phenotypes here on this list are quite outlier phenotypes in terms of Russian range of phenotypes. So um, she's definitely quite dark by Russian standards, quite exotic. All right, now let's look at the biomarkers. And she is dark and exotic despite having the blue eye haplotype 2 mutation, the main mutation that defines blue eyes, blonde hair, and pale skin, and HERC2. Despite having that, she's still very dark. So I guess it goes to say that you cannot accurately predict eye color and hair color and skin color if you just go by this one mutation. You have to go very polygenic. So um, for vitamin D, she's got a predisposition to higher levels of vitamin D. For cholesterol, higher levels of LDL, lower levels of HDL cholesterol, which is bad. Both of these are bad. You want to have the reverse. For glucose, she's got lower levels of glucose, which is bad. For hemoglobin, she's got lower levels of hemoglobin, which is good. She's got higher blood pressure, which is bad. She's got lower level of iron in the blood, which is bad. She's got a lower level of sex hormone binding globulin, which is bad. She's got higher level of red blood cell count, which is okay. And she's got higher number of base pairs for expected telomere length, which is really good. So she's got a predisposition to live longer. And she also has a higher predisposition to height, so she's got some predisposition to be taller as well, which is really cool. All right. Now let's look at the polygenic risk scores, and we are going to look at only the ones that are either really significantly below 1 or really above 1, so stuff that's substantive. So she has very high odds of hemoglobin E disease. She has low odds of migraine. She has high odds of lupus. She has high odds of gout. She has high odds for eczema. She has lower odds of polycystic ovary syndrome, which is really good to see. So she's quite protected from PCOS. Quite good to see. She has lower odds of AMD. She has higher odds of rheumatoid arthritis. She's got slightly higher odds of asthma. She's got slightly lower odds of myopia. She's got higher odds of male pattern hair loss, which is very typical for West Eurasians and Europeans and people of European descent. She's got slightly lower odds of atrial fibrillation. She's got very low odds of cardiovascular issues. So from this, we can assume that her homocysteine panel and cardiovascular panel are going to look really good. She's got high odds for ADHD. Wow, really high odds for ADHD. She's got average odds for unipolar depression. She's got very low odds for bipolar type 1. She's got very low odds for schizophrenia. She's got very high odds for type 2 diabetes, and she's got average odds for type 1 diabetes. And she's got very low odds for Alzheimer's and very high odds for multiple sclerosis. So multiple sclerosis is the one thing that she's got very high odds for. So perhaps the thing that we have to watch out for in this file is multiple sclerosis. I'm going to keep this in mind. Multiple sclerosis is something that we have to watch out for. And perhaps the HLA gene panel as well, because the HLA gene panel does have a lot to do with multiple sclerosis. We might scroll up and see asthma and lupus as well, and type 1 diabetes, because they also have to do with the HLA gene panel. So let's look at type 1 diabetes. It's a little bit above average. Let's look up asthma and lupus. Asthma is above average as well. And what about lupus? I don't see lupus. Lupus is above average as well. So there is perhaps something bad going on with the HLA gene panel. We're gonna get to that when we get to it. So for the cancer section, looks like she's got 2 risk variants for breast cancer out of 14. That's typical. That's common. Very low odds for prostate cancer. Very high odds for brain cancer. Wow. So we remember the risk score for multiple sclerosis. Now we gotta keep in mind also the risk score for brain cancer, glioma, and 7 risk variants for testicular cancer that are also very cooked genotype in KED003, homozygous risk genotype in KED003 as well. But that's typical for Europeans to have, so there's nothing uncommon, nothing unusual here. However, the risk score for brain cancer, glioma, is very, very uncommon, very unusual. So we have to keep this in mind. Definitely very much predisposed to brain cancer and the multiple sclerosis. She's got no risk variance for celiac disease, no risk variance for GSS, 13 risk variance for Crohn's out of 24, which is really, really high. That's really, really, really high. That's actually kind of crazy. So she's predisposed to Crohn's as well. And we don't see anything else in this file that's concerning. Yeah, we don't see anything else. But what is crazy is the Crohn's disease risk score and the brain cancer and the multiple sclerosis. So those were the 3 conditions we found in this file that probably will go on the thumbnail: multiple sclerosis, brain cancer, and Crohn's. But I don't know. This is what we found so far. Let's go over the monogenic traits and find out if there's anything else. So for the warrior versus warrior, she's definitely more of an intermediate phenotype, intermediate dopamine levels, and intermediate ability to tolerate stress. For D2 dopamine receptor side panel, she's scoring less D2 dopamine receptors, which really goes well with her scoring lower for schizophrenia and bipolar. So she's got lower predisposition to such conditions as schizophrenia and bipolar, less dopamine D2 receptor sites in the brain. For levels of 5-HT and serotonin, she's got predisposition to intermediate levels of 5-HT and serotonin, so intermediate predisposition to such conditions as anxiety and depression. For autism, she's scoring intermediate odds of autism. Did I skip anything? Nope. For lactose intolerance, she's scoring lower odds of lactose intolerance, so she's definitely lactose persistent. Very good to see. And for OXTR and empathy gene, she's scoring, looks like, average or lower level of empathy. Very, very interesting based on these 4 SNPs. She's not a carrier for the C282Y hemochromatosis mutation. Now, for multiple sclerosis, she actually is this HLA DRB1 1501 homozygote. So she carries and she's a carrier for this variant of DRB1 as well for multiple sclerosis risk. So she's definitely got risk variants for multiple sclerosis in the HLA gene, which is really unfortunate. Really, really unfortunate. We're going to have to look at the whole HLA gene panel in a couple seconds, maybe in a couple minutes, and see if there's anything else there as well. She's got all European genotypes in EDAR, so European facial morphology. She's got nose pointing up, she's got intermediate nose size, and she's got lower rows of missing teeth, which is really good to see. She's got 1 HLA risk allele in this variation for vitiligo. Alright, but she doesn't have any risk variants in HLA for vitiligo in HLA-A, which I did move to the HLA-A panel on the HLA to the HLA-A section of the HLA gene panel. I remember in my previous video I noticed that I made a mistake putting it into HLA-D. I did fix that. Notice that I made a mistake and fixed it. She's got no micropenis, which is really good to see. Always gotta check for that. Mix of muscle types, slightly more sprinter than an endurance athlete. And highest odds of obesity and major depressive disorder. Very, very interesting. Alright, what else can we talk about here? She's got no risk variants for familiar Mediterranean fever. She's not a carrier for cutaneous albinism type 1B mutation, so she's not albino. And for cancer, she's got lower odds of epithelial cancers, but she is scoring very, very high for glioma. But it looks like, well, this one is in 8Q24. So the thing is, this cancers panel takes into account only stuff that's in 8Q24. But for glioma, most of it is not in 8Q24. Most of it is in other genes, right? So the only genotype for 8Q24 that's for glioma is this one. And here she actually does have a risk genotype. But it looks like for all the other variations that have to do with glioma, she also has the risk genotypes, which is really crazy. I think that her score is actually the highest you can score for glioma, which is really, really insane. I think it might be the highest you can score. So for cancers, overall, her results is really good because for 8q24, the only risk variant that she has is the one that's highest odds for glioma. But for glioma, she's completely messed up. For glioma, her score is the highest you can get that's possible at all. So that's kind of crazy to imagine at all. But for cancers, for epithelial cancers, she's doing great. She's doing great. Her score is great. Lower odds of epithelial cancers overall is great. All right. For rare diseases and trace panel, she's got strong predisposition to hemoglobin E disease, which is we went over that. She's scoring very high for that. Let's see what else. We don't see anything else here. We don't see predisposition to celiac disease in the HLA gene, and she does have one protective variant from HIV and HLA-C, which is really good to see as well. So some protection from HIV. And now we want to see the HLA gene panel, and the HLA gene panel here is actually not so bad. Still, the highest thing she scores is lower odds of autoimmune disease. Let's check the HLA genotypes and see what genotypes here are malicious, which ones are good. So she does have some malicious genotypes even in the HLA-A genotypes. So this one here, which leads to lower levels of antibodies. This one, which leads to higher odds of multiple sclerosis. There's HLA-B looks like everything is good. HLA-C looks like this one is bad, is a bad genotype. But overall, everything looks good. HLA-D, this is a really bad genotype, but overall, everything looks quite good. So really, it's only the multiple sclerosis variants that were quite bad. Yeah, and besides the multiple sclerosis variants, everything was quite good. So overall, the HLA genotype is still quite okay. It's just that she had two genotypes that were quite bad for multiple sclerosis. And for homocysteine panel, she's scoring intermediate levels of homocysteine. So okay, I think I skipped over the cardiovascular panel. It must be really good then. Let's look. Yeah, it is really good. So 80 to 53% for lower odds of cardiovascular issues. It is really good. Yeah, it had to be really good because she scored like 0.4 for odds of cardiovascular issues on the cardiovascular issues panel for the polygenic risk score page. So it had to be really good because the homocysteine panel isn't. I mean, it's good as well, but it's not like super good. And the cardiovascular issues page on polygenic risk score panel, it's a combination of the two. So if one is okay, then the other one has to be really good to compensate, because it's a combination of the two. Okay, so for muscular dystrophy, she's got no risk variance in any of them, and she's got no risk variance for ADL. All right, for colorblindness panel, she's got no risk variance for colorblindness in OPN1SW or MW, and for FTO gene panel, she's got predisposition to intermediate odds of obesity based on 1, 2, 3, 4, 5, 6, 7 SNPs. For syncope panel, based on 2 SNPs, she's got lower odds of syncope, which is really good to see. So she's got some predisposition against syncope. And for biotraits panel, it looks like she's got 2 copies of the farmer's COTCL1 gene variant, which means she has a selective advantage in processing carbohydrate-rich diets, presumably including those with lots of sugar, which is really good to see. Now for blood group, she's got blood type O, definitely a very definite prediction at 90.6% likelihood. Now blood type O is the most common blood type worldwide, and it's very cool that we see this sample is predicted to have blood type O. Thank you for watching my video here on YouTube. If you enjoyed it, please do leave a like and subscribe and comment whatever you found interesting in this video and whatever maybe you want to add. Maybe you thought I maybe you want to say something that I did not say. Perhaps you want to clarify something that I mentioned. Just add a comment. That really helps the video and the algorithm. By the way, check out the description of the video. In the description, you will find links to buy my Trait Predictor. Trait Predictor is an app and software that I developed to generate a health and traits and ancestry report for a DNA file in a microarray sequence format that includes formats of MyHeritage, 23andMe, and Ancestry. So you can generate a health, traits, and ancestry report like the ones you see in these videos that I make on YouTube for your own MyHeritage, Ancestry, or 23andMe DNA file. So make sure you check out my trait predictor. The links to buy my trait predictor executable will be on the description of this video. And also you can buy a report in case you are too poor to purchase their executable, or perhaps it doesn't work in your machine. You can purchase a report for only $4 currently. It will be even cheaper once they automate it, but that's going to come a little bit later. When they automate it, it's going to be even cheaper, but currently it's $4. The link to purchase the report is going to be in the description of the video as well. So check out the description of this video. Thanks for watching. Make sure you leave the like and subscribe. Goodbye.